Hi, Hannah. We're so happy to have you on the Empowered Nutrition Podcast. Welcome.
Hey, Erin, thanks for having me. I'm excited to chat with you today.
Same. This is secretly my favorite topic. I am fascinated completely by epigenetics, which we'll talk about what that even means. But before we get too crazy with that, maybe you can just share a little bit with our audience about your background and how you got into the space.
Yeah, definitely. So I'm excited for everyone who's listening. I come from, a background of biology, entrepreneurship, which is kind of odd because no one in my family ever was. They were all more like business oriented, which I guess that's, may align with the entrepreneur type of spirit.
Fair.
But I've always been, interested in, how the body works, science. So I originally am from Ohio, came to University of Kentucky to do my undergrad, and took a really interesting position afterwards. Was going to take a year off school and actually go back to grad school, but ended up really working at this pharmacy in the compounding space that specialized in unique peptide production.
Mm.
And that was a big turning point in my career, just because that's when I first realized there's this entirely different health system out there rather than the traditional one, which everyone who's like in our space, Erin, I see you shaking your head, goes through this moment in their career where they're like, aha, there's more than just that sick care model. So
Mm-hmm.
that's where I really, became interested in this all cash pay, integrative, functional, anti-aging space, if you will. And we really then created my company, Now True Diagnostic, that specializes in, epigenetic DNA methylation testing that we'll get into. But on the entire premise that we needed more quantitative data behind how those peptides really worked.
Mm-hmm.
And really tested that with the biggest risk factor that we still know today being aging, right? How can we measure aging and kind of slow that down and use those peptide and pharmacy products in order to do that? So fast forward from 2019, up until, 2024, up until now. So that was 5 years ago. We sold the pharmacy, back in 2019, and then slowly started focusing on True Diagnostic and creating these predictors really for overall health, which has been such a fun journey.
Yeah, I mean, it's so impressive. I mean, especially because I feel like I first heard about you a few years ago, and I think it was from like Mark Hyman at this conference I was at. So like somehow within a couple of years, you had Mark Hyman using your test. So good job.
Yeah, thank you. Thank you. I know we've known each other for quite some time. It seems like Erin and our paths have crossed, which is always
Yeah,
nice to catch up. I think wasn't he at maybe the IHS conference?
it was that. Yeah.
Yeah, we had a ton of people reach out afterwards, like, "Oh, Mark Hyman's using the test," and
Yeah.
yeah, not sponsored at all. Just again, I think stays on the cutting edge
Yeah.
outcomes and what's available, and maybe believe that our testing fell within that realm at that point, which was awesome. Yeah, and he
Yeah.
continues, to I think be a big advocate just for aging, longevity in general.
Yeah. I didn't realize that you had kind of started in the world of peptides, which makes sense because that can be one of the most powerful uses of peptides and as around aging. And we could even, I think it's like people might not realize how much peptides have come to the center in the sense of GLP-1 medications. I think a lot of people don't realize that those are peptides as well. And like we're starting to see some signs that they may have, aside from the obvious metabolic impacts, they like definitely impact all over the brain. And there's some early research around like dementia and GLP-1 medications, and pain is another big thing I'm seeing. So
Yeah.
peptides are really powerful, but I could see how if you're in the world of peptides, it's a little shady, it's a little confusing, it's a little unclear what to do. And so maybe tell me if I'm imagining
Yeah.
this, but maybe that's kind of where this part of where this idea came from of like, well, what if we had some tests that would kind of tell us like who needs peptides and potentially like what kind of peptide?
Yeah, you're exactly right, and that's kind of why we got out of the space. We were actually the fastest healthcare company, in the no fastest healthcare, company in the state of Kentucky, fourth fastest in the nation, actually, when we had that pharmacy, but it was a compounding pharmacy, right? So we were able to do things that were not FDA approved, and we got a lot of backlash for just how quickly we were growing. And those who are still getting compounded peptides, there are a lot of different rules and regulations now.
Yeah, I think the FDA is really locking this down.
Yeah, but you're right. Like semaglutide is going to be one of those peptides. Again, that's going to be commercialized in a different way. So it's interesting. I mean, regardless, and I think with everything, you can make the argument, we just need more data, we need more tests, we need more information behind them. We do have a really cool clinical trial we're doing right now. We did it, kind of an internal trial with the GLP-1s with some of our healthcare providers and how that's affecting aging, but we're doing a larger one even with Cornell University right now, with thousands and thousands of subjects to see how these markers we're measuring and biological aging is actually changing with those GLP-1s. So I'm really excited for that one.
Same. I am too. Gosh, I'm so tempted to just really go deep on this, but I'm gonna hold back because I think we need to tell people about your test. Let's talk about maybe just overview. I'm sure you have a spiel on it, but tell us about your test. Tell us about what the science is and how it looks at aging.
Yeah, absolutely. So, even maybe backing up and talking about like biological aging versus chronological aging. I know that's silly, but to define that, right? You have like how old you are, your birth date that only increases with age. But we know, like, think of how old you are chronologically. You probably know people who look way older than you, right? Physiologically.
Yeah.
And then people who look way younger than you. So that's what we're looking at. There's this idea that you're actually aging at a cellular level, and that's going to be your kind of biological age. So there's all different ways to measure biological aging. The way we actually measure it is pretty unique. We're looking at what's called epigenetics, which Erin, you mentioned was your favorite topic.
Obsessed.
So epi is just a Greek prefix. It just means above or on top of. We're kind of looking, what's happening, to the DNA itself, because you're not going to change your genetic sequence. Your genetic sequence is, 20% of your health outcomes. It's 50% from parent one, 50% from parent two. It's that nature aspect. But then you have your epigenetics, which is going to be more of that nurture. It's about 80% of all of your health outcomes in what you do. And you're really going to be in control and be able to change your epigenetics. And for the most part, just for the point of this conversation, they're not necessarily all inherited from your parents. A very small fraction is, but for the most part, they're not going to be inherited. So again, it goes back to you and like your health and puts the power in your hands, because you're no longer you're no longer
like a pre-coded defined destiny with your health, like
exactly.
The way that we thought in the 90s when we started to map out the human genome. It was like, this is it. We're going to map out the genome. We're going to know everybody's health future, and that's going to be the end of the story. And now we've learned it can be further from the truth. It's more like that's kind of just defines what the switchboard is, but the function of the switchboard depends completely on how the switches are flipped, and your environment is what flips these switches, not your pre-coded genes. And so what you're looking at, it sounds like, this is not a perfect analogy, but you're not looking at the genetics you inherited from your parents. You're looking at how that switchboard, what's the configuration of those switches and the impact that it has on health.
I love that. Yeah, you took the words right out of my mouth. I was looking for something there. I think I was going to say, victim of your genetic makeup, right? So it's pretty powerful, and I've never actually heard anyone compare it to like a switchboard like that. But I like that. I usually do like the light bulb or the light switch. But I like the switchboard because it's definitely more complicated than just the light switch, because it's everything. So. Yeah, it's super unique, kind of a personal story I use as well. I just gave a lecture at a conference in London and kind of used this story for the first time and felt like it was explained rather good. But, my grandmother passed away from Alzheimer's, and it was awful, right? Like everyone knows someone who has a neurodegenerative disease. So that's why I bring up this example. It's just so common. And like, that was when I was a senior in high school, and I went and I got my genome run like right away. I'm like freaking out. I had no idea what epigenetics was at the time. And I have one of the APO E epsilon
Okay.
variants.
Copy.
Yeah. So I'm 3-4. So I have one of the, copies. Well, it's kind of the second, like to worse, it's the second worst kind of combination to have.
Yeah, because you're not homozygous, you're hetero.
Yeah.
Yeah.
So, increased 2 to 3 times more likely than like the average person to get diagnosed, and then earlier as well. But there are actually studies that have come out more recently talking about things you can do from an interventional standpoint, lifestyle, supplement, medication, procedural things to change the DNA methylation or, epigenetics of that functionality of that gene and then reduce your overall risk. So it throws it again back in your own hands, which I didn't know that when I was, in high school. I was so scared. But
Yeah,
that's what's so cool about this field.
very cool. That's amazing. So it sounds like, and then tell me a little bit about how the algorithm works. So you, just in general, maybe go from there on it. So you are somehow looking at
Yeah.
epigenetics, and I think specifically methyl groups,
Yeah.
probably. Yeah.
Yeah, the DNA methylation I just hinted at too. So there are a ton of kind of like epigenetic modifications, we call them. We look at the DNA methylation, and if something's methylated, it means that gene's turned off. It's not functioning. But if it's unmethylated, then that gene's turned on, and you're kind of going through that central dogma and ending up with that phenotypic outwards expression. So you're exactly right, Erin. We're looking at just a CH3 group, a carbon, and 3 hydrogens.
Yeah.
That's what I mean by methylated. And again, flipping that switch or going back to that switchboard example. So at True Diagnostic, what we do more specifically is we measure about 1.2 million of those DNA methylation markers. So it's a lot. And what we can get from that data is pretty incredible. We can tell you, I'll just give a couple examples, but we can tell you how much you've smoked across your entire lifetime, which is more accurate than self-reported smoking status.
Oh.
Scary. We can tell you your zip code, where you are based on your environment and those exposures, kind of, the toxics of the air pollutants in your specific location down on the zip code.
Wow.
Now, this is more of a real world example, and it's a weird one, but I have a reason for giving the example. It's neurosyphilis diagnosis. So we're actually working on this. So it's a really kind of rare diagnosis. But what you do is you basically compare, people who have neurosyphilis, people who do not. You can see the pattern, what we call your fingerprint of those DNA methylation markers in people who have neurosyphilis, people who do not. Now, I use this example because with our testing, you just test with a blood spot card. It's really easy. If you wanted to see if you were diagnosed with neurosyphilis, you'd have to go into the office. You have to pay about $5,000 to $10,000 out of pocket, and you'd have to get an extremely invasive lumbar spine puncture. So that's, again, how this testing can really help people, right? So everything I'm describing, it's like a fingerprint. You're just looking at patterns and you're comparing them throughout the body with a blood spot card, with a couple drops of blood. That's all you need to look at these patterns.
So fascinating. Yeah, I love that. That's so cool. And to be honest, I've taken your test, so it was awesome. And there's a lot of really cool things that come out on it. But I think the keystone of it is you really see, as you said, I guess you could call it almost like an internal age or like a true age, and it's gonna be it could be a different age than your biological age of what it says on your driver's license, right? So I guess one thing that I like about that is that when you're, like you said, in the sort of sick care model and you're seeing oh, your cholesterol is high or your blood sugar is high, those are indirectly related to a future risk of a true problem. You don't actually feel a blood sugar of 120 is a problem, but you feel like a late stage diabetic foot amputation is one extreme example, right? So, where you feel a heart attack for sure. So it's a very inexact sort of imperfect thing that we're doing with the sick care model of seeing, okay, well, because you have these elevations, there's more future risk, but we don't really know how you're doing. And so I like how this is showing, like, okay, let's say that I do have concerning things about my health and I implement some changes. Um,
Mhm.
well, the truth is, it is, how do you quantify of like how well that's working out for you? If you with your test, I like how it's like, okay, then you can get like a less expensive repeat test over and over again. You can do it like to check in on, okay, like how's that actually working out for you? Because lifestyle change is hard for people to stick to,
Yeah.
especially if they're not getting feedback. Like, is it really worth skipping my favorite cinnamon bun every day or not? Because I can't tell. But if you act, I feel like it could be very rewarding to see that, oh, okay, I was aging faster than I should, and now I can see that my internal age is actually reversing, and you can even have it be younger than your true age. It's more of an indication, I think, of like health outcomes than something that's like less exact. But I don't know what you think.
Yeah, no, absolutely. And again, I think it all comes down to, yeah, what's the one thing you can test that is kind of like the end all be all
Like
or
all
ruler of them
encompassing.
all. Yeah, all
Yeah.
encompassing. And I think again, it's not new. Aging has always been the number one risk factor for all cause mortality and morbidity. So
Hmm.
even if you look at, I usually show really like pretty. There's a really pretty graphic, and I can send it to you afterwards if you want to like put it in the show notes or
Sure.
something. But if you look at the top 3 killers in 2020 in the US, you have your heart disease, you have COVID-19, you have cancer. All three of those, if you look at the risk factors, I mean, people think of like, male versus female. They think of, oh, are you a smoker? Are you a drinker?
Hmm.
Hypertension, there are a couple
Hmm.
other risk factors in there as well. But if you actually line them all up in a bar chart and graph, aging, it just skyrockets. I mean,
Hmm.
it as a risk factor trumps and dwarfs all of those other risk factors,
Hmm.
uh, which is just crazy because, I still almost can't believe it that aging is even a risk factor, right? But it sits at the center and the core of every single disease. We become disease because we get older. And
Hmm.
if we actually are able to have a test that quantifies that number one risk factor, so the biological age,
Yeah.
you can get it, like you mentioned, you look at it, it's tangible. You're like, oh, wow, I'm aging faster, I'm aging slower. And then again, because it's based on epigenetics and the DNA methylation, those on and off switches, the switchboard, you can do things to slow it down. So it's very actionable as well, I
Hmm.
think is the key. Now, another key of this testing, and something I'm again revisiting and starting to realize just how important that is the retesting. You have to retest, right? Just like you would with your CBC panel or your, hormone values, every, 6 to 12 months, or
Hmm.
so, or even a little bit sooner. Um, that's where the value comes in because, like you mentioned, yes, should I be doing that cinnamon bun? Oh, bun makes my age go up. But what if I did, I don't know, carrot cake, right? Maybe
Yeah.
that makes it go down. It won't make it go down, but maybe
Yeah.
it's a healthier dessert, right?
Sure.
Stupid example, but you get the point.
Totally. Yeah, it's because there's a lot of controversy in the health space. So, we get patients who are convinced they should be on a carnivore diet, and then we get patients who are convinced they should be on a vegan diet and everything in between. It's like, well, how do you really decide after 6 to 12 months of doing that how well it's working for you?
Yeah.
Right? This is, I think, better than a more like single point thing, because it's more true to like the actual endpoint goal that you have, which is wellness and health and longevity. Nobody actually cares what their cholesterol level is. They care about not dying young from heart disease, right?
Yeah. Yeah.
So, yeah.
That's an interesting way to put it too. And yeah, I think, the biological aging, to be again completely transparent and honest, may get, it's something fun, it's flashy, it's sexy when you hear about it.
Hmm.
I think if you're really thinking of it as a biomarker and something you're taking seriously, a lot
Hmm.
of people go, well, so what? Who cares about biological age, right? It's just a trend. It's not here to stay, not here to stay. Well, the argument there is, you're right, right? We have to validate them just like at one
Hmm.
point CRP, IL-6, triglycerides, HbA1c, fasting glucose was all validated. So, there are questions we ask ourselves. Is it true? Meaning, does it have analytical validity? Is it meaningful? Does it have clinical validity? And is it useful? Does it have clinical utility?
Mm-hmm.
I think that last part, is it useful? There are certain things, like, you could argue what these things are, but maybe a list of like 5 to 10 almost checkpoints for the outcomes that you can kind of ask yourself or go through. And we're seeing a lot of improvements in those checkpoints in the last couple of years with the biological aging and kind of these algorithms, the machine learning, the AI we're using, where they keep getting better and better and better. So I think the biological age clocks, as of right now, I mean, it can always change, are here to stay. Point being, they're predictive of outcomes, right? Long-term health outcomes. With our new biological age clock we just created with Harvard, what we call omic M age, based on kind of this idea of the multiome, the different layers you have in the body, can predict death with, a 92% accuracy rate, which is crazy. We don't report out on that, but
wow,
it's getting closer and closer. And just to give a comparison, again, you're probably like, well, yeah, what does that mean? To give a comparison, you can predict death with just chronological age alone, but that's only a 72% accuracy rate. So again, if we're looking more at these underlying biological markers that have more significance, we're getting better at predicting outcomes, and that's really the key.
That's so cool. And what makes me think about too is I wonder if people might be wondering, okay, methylation, you're looking at how the switches are flipped, but how do you translate that into the age? So tell me more about how the algorithm is derived. Like, what type of data goes into that? Like, is it go ahead?
Yeah. So I think it depends on all of the algorithms, or I should say all of the algorithms are going to be different. So I'll kind of give that one that I just mentioned with Harvard, if we want to kind of like stay on the same path. We can go into any of the others too. So I think this is one of the best clocks. And, why do I think it's one of the best clocks? Well, because it's, number one, predictive of outcomes, like I just mentioned. It's published in a peer-reviewed journal. It's predictive of again, those other outcomes. It's correlated with quality of life-based metrics, health span and lifespan. It's very precise. It responds to interventions we know beneficially affect the biology of aging, and even explains why you're aging as well. So that's why I said I think it's the best. But let me answer your question directly and tell you how we created it. So what we did for this specific clock is we looked, and this study took about 3 years. We took 5,000 patients from Harvard's biobank cohort. So we partnered with Harvard because they have this awesome cohort where we can look at outcome data with the samples, right? We can look at someone's DNA methylation markers and then at one point in their life and say, oh, wait, that person actually developed a disease later. What did their fingerprint look like, right? So we took about 5,000 patients. We measured 27,000 untargeted proteins on them, 8,500 different metabolites, 61 clinical lab variables, and 1 million of those DNA methylation markers.
Wow.
So we're measuring all sorts of things. So you're probably thinking, well, why are you measuring other things besides methylation, right? Well, the more biomarkers you're able to measure, the better the algorithm you're able to create, because you're just fueling it with more information, right? So what we're able to actually do then, after we train the algorithm with machine learning AI, is we can tell you what you need to work on to lower your biological age within the algorithm. So we set a threshold and said, hey, we asked kind of the model, which clinical lab values, metabolites, and proteins are the most statistically significant and correlated with aging. So, say your results come back, you get a score, you get a biological age, you compare it to your chronological age. But I can actually say, I'll just pick on you, Erin. Hey, Erin, your red blood cell distribution width is super high. We want to lower that because we know lowering that is associated with slower aging. And to lower that, we may make nutritional recommendations. So increasing iron, B12,
B12,
folate,
folate.
vitamin
Yeah.
C for iron absorption. So you can
Yep.
do that through diet, right? Meat, leafy greens, liver, peppers, citrus fruits, tomatoes for the C to help absorption. Or you could supplement with it, right? You take an easier route out, or supplement if you need more. So that's what's really cool also about the Omic MH and how we created it, is because we're actually able to tell you why you're aging that way and give you specific recommendations on what to do about it. So that is a very different, distinct algorithm. Hopefully that was a little bit of a preview on how we created it. I know it can be a little bit difficult when you get into like more of the machine learning and the modeling.
No,
But
that's great. The inputs are, it sounds like, specific health cases where, okay, we've got the biomarkers, we've got the epigenetics that were measured, and then over time we saw the health outcomes that these people had, and then when you get enough of those data points, you can build out an algorithm of like, okay, this where it allows you to translate the epigenetic results into the health prediction.
yeah, you're exactly right. And to be more maybe specific on what I'm talking about, the red blood cell distribution with example that I gave you, that would be an EBP. It's a new term. It's an epigenetic biomarker proxy. So we created the term, we coined
Okay.
it, which is really cool, I think. But basically that means because of how we trained it with all of those biomarkers, we can only take a blood spot card, test your epigenetics, and report out almost anything, right? Like the clinical lab value, like the metabolites, like the proteins, like the neurosyphilis diagnosis, right? So it's kind of it speaks for itself, EBP, but it's just, the idea that we're using DNA methylation as a proxy, kind of the input, and like you mentioned, something else as the output.
Wow, that's so neat. I think it sounds like that clock would be on your like panels that you already offer. Is that true?
Correct. Yes. Yeah. So not the neurosyphilis, the
Yeah, but that
I'm
clock.
just kidding. Just to be clear, yeah, it's not something we offer. It's still in research development, but there. But yeah, that's something we offer. So we give you the age, right? We give you the Omic M age. We'll tell you if you're older than younger, according to where you're at in our population and how that kind of looks, and then say, hey, this is what came up as being significant. It held a high weight in you, and you need to work on this. In the future, what we're working on right now is kind of some pretty cool reporting. We'll call it maybe like true eval, or kind of like a vitamin type of test, right? Really any type of clinical lab value, any type of metabolite or protein, where we can report out almost 4,000 of those EBPs with a 1-to-1 ratio. Our correlation values of about 0.9 as well. So it's really cool research. Again, for a fraction of the cost, which is key. Just a blood spot card, which is still technically an invasive sample because you're, getting blood, small sample, and then keeping, all of those results kind of in one place locally.
So tell me if I understood that correctly. You're saying that you could take the blood sample, and just by looking at the epigenetics in that blood sample, you can report on what you can predict that what that person's lab marker, a bunch of their different lab markers would be, with like a 0.9 correlation.
Yeah,
Which is high.
absolutely. Yeah. So it's coming. Yeah, it's definitely almost here. So that's still, I would say, in research phase, but it's absolutely coming, and getting really close as well. So yeah, it's going to cause a major, I think, paradigm shift in our traditional testing and what we're doing today.
Yeah. Well, it's a super dumb question, but is it that the biomarker, let's say that you're talking about like a blood glucose, is it that blood glucose alters the epigenetics, like high blood sugar changes your your switchboard switches, or
Exactly.
is it the opposite, that like your switchboard configuration impacts your blood sugar and that
I
will
think that's the $1,000,000 question. I would say,
okay.
yeah, we still don't know, right? Yeah, what's
Yeah.
happening first? Like,
You just know there's tight correlation between the 2.
exactly, like, yeah,
Yeah.
are you becoming diseased because, your DNA methylation markers are changing? Or, or
Or
are
maybe
your
they're not even
methylation.
causing each other. It's like the external thing, the cinnamon bun is impacting both. It's causing high blood sugar and it's causing the epigenetic shifts, but it's not that the 2 things are one of them is causing the other. It's that there's the third external, like the environmental thing is
Yeah.
like doing the shift on both of them.
Yeah, exactly. I think there are so many options, right? There are so many
Yeah.
ways you can kind of go there. So yeah, it's
Wow.
like what is really happening, right? On kind of that cellular level, and then yeah, what's kind of causing it? And it's probably a mixture of, I would say, all 3 of them, right? If we had to guess, I don't think it
Yeah.
might be 100% one thing, 0% another, but definitely,
Yeah.
yeah, a combination of them. So it's a really cool field to be in, just even pondering that question, right? Like, you could study that question for the rest of your life and, maybe, just get the tip of the iceberg with all of everything else still underneath.
Yeah.
So yeah, we're just
And
scratching the surface.
it's fascinating that those correlate so highly. That's
Yeah.
really wild.
Not all of them do, right?
Some of them.
Yeah,
Yeah.
some of them do, and obviously, the better we train them, the more correlated they'll be. Um, but right now, even to give another example, we could report out your VO2 max, your FEV1, your grip,
Stop.
your gait speed, yeah, all of them.
No.
Yeah, in the same exact way, right? So it's still an EBP where we train them with the actual physical outcomes. And then we're able to just give you that outcome through the epigenetics and the DNA methylation.
Wow.
So,
Or another thing this makes you think about, because it's like, oh, okay, well, like, okay, I could see how exercise would cause epigenetic impacts, obviously, where on different genes are flipped over there's certain ways, and it's going to cause let's call it not even just exercise. We'll call it like high intensity exercise. It's
yeah.
going to cause the epigenetic shifts and the increase in VO2 max.
Mhm.
So that's like the third thing we talked about, where it's like the external thing causes these 2 shifts, and they're going to correlate with each other, where one can predict the other. And it kind of makes me think about like, wow, you could even it's fascinating. One of the fascinating things that epigenetics with me is the way that like the switchboard configuration is inheritable to some degree from like one generation to the next, such that like say like studies, know more than me, but like where when a mom is under like a lot of stress when she's pregnant, it can literally impact the epigenetics of like her offspring like in a significant way. And like it's kind of fascinating to think about, like, could you use this to almost like, okay, you get like a blood sample from like a baby and say, oh, okay, yeah, this baby has like much increased risk of anxiety or like depression. Not that I necessarily know what you would do with that information, but it's like kind of wild to think about, like, oh, like so much of their health futures is like already right there in their blood, and you could potentially like find it.
Yeah, yeah. That's one of my favorite things to talk about. I haven't talked about it in a while, actually, but what you're describing, it's a mouthful, but it's transgenerational epigenetic inheritance.
Yeah.
So it's really cool. There's someone from Washington University named Dr. Michael Skinner. He just studies it in animal models. I heard him speak at a conference when I was still kind of early to epigenetics, but a couple years ago. And when he spoke, I was like, we're all screwed. We're all doomed. I
That's
was like,
encouraging.
oh my gosh. And like, and you're too late. Like, yeah, like there's nothing we can do about it, really. Like,
Yeah.
there are some that are passed, yes, from older generations. Like if your grandmother or great grandmother smoked, when she was, pregnant and
Yep.
things like that, which is really common,
Yeah.
back in the day.
Yeah.
Um,
Like super
and
common.
my grandmother smoked when, yeah, she was pregnant with my mom, which is something I just found out recently. So I'm digging. I'm
Fun.
excited. I'm like digging into that a little bit more too. So, yes, epigenetics is changeable. Some of those are going to be malleable, but in the way that it's passed on, some of them are not. And that's what I mentioned at the beginning. Like some of the markers are going to be pretty stable and you're not going to be able to affect them. But for the most part, yeah, the epigenetics is going to be changeable. So Michael Skinner, he studies it in animal models, and he's gone back like 10 to 15 plus generations, and he can actually track it through mice and rat models. It's just harder to do human studies, obviously, because it's such a new science, and we might not have the DNA from like our parents or grandparents or great grandparents. So you're not, there'll be more studies coming out in the future on that.
Yeah, it's so good. I mean, I guess there's two sides to every coin, but I think what I'm hearing you say is it's like, okay, you've got this switchboard with your switches a certain way, and then like some of the switches can be like massively impacted by your decisions and your environment that you put yourself in, but some of them are kind of stuck, like they're just kind of not movable, and some of those configurations might be problematic in the long term for your health, which can be upsetting. But on the other hand, I feel like, I guess in clinical work, it can be kind of heartbreaking to see so many people that are working so hard on their health and they're doing so much more than other people, and yet they're not doing as well. And I guess the silver lining of knowing that is just that, like, I think that's a lot of what's happening with with a lot of these patients. It's like your switchboard configuration is not optimal, and you can change it to some degree, but it's almost maybe validating to say like, but you can't fully get the switchboard of whatever, insert your favorite athlete here or whatever, but like, or
Right.
superstar or whatever, but you can't just eat the right food, because I feel like social media especially puts that kind of thinking in people's head of like, just tell me the right smoothie to make and the right fasting routine and the right workout, and the clouds are gonna part, my health is gonna be like perfect. And
Yeah.
they'll try like so many things and like so many practitioners and so many aggressive diets and supplements, and they're just kind of flailing around looking for that thing. But it's like, in the end, I agree with you. Just working with so many people, I'm just confirmed that like there's really only so far that people seem to be able to get.
Yeah. Yeah. I think one comment back to that is, yeah, there's always the question of what should I do to lower my biological age? Like, Hannah, what works? What can I do to shorten?
Yeah.
And like, I can tell you two things, and neither are probably going to be super helpful. Number one, here's what the studies say, right? There's still large population studies, right?
Mhm.
We're not as an individual, we're not a population. We're a very unique,
Yeah.
we have a very
Yeah.
unique makeup in that sense. Um, so yes, you can still follow that. And that's probably a good place to start, right? If it works for you, retest and actually do the testing yourself, but it doesn't mean it's
Yeah.
going to be successful. The second thing I can tell you is this is what works for me. And the reason I can tell you that is because I've been doing this longitudinal testing for a while now, right? And can push those boundaries and can push those limits. Again, I think it comes back to, hey, if you don't know or if you are interested, and you mentioned this at the beginning a little bit, is, hey, do the cheaper kit, right? Retest your pace of aging every 2 to 3 months or so to get feedback on that number one risk factor.
Yeah.
And that magical smoothie that you're seeing from that
Yeah.
influencer, like, probably has a ton of sugar and probably has a ton of carbs in it. And like,
Yeah.
is, worse than your biological age when you dive into it at the end of the day.
Yeah, recheck on it. Exactly, and, like you said, I think it's depending on what your specific challenge areas are, it's gonna be different things for different people.
Yeah.
So
Yeah.
it's I think the way you're testing, the way I'm obviously been able to spend less time marinating on thoughts on this, but the way I think to use it is not necessarily that you use it to come up with some like paradigm shifting idea of what someone's health plan should be. It's more a better way to tell them if it's necessary to change their health habits. First of all, like, are you aging
Mhm.
quickly compared to your the calendar. And then if you do implement some type of health plan that's just the evidence-based thing that we would have done anyway, basically.
Yeah.
Um, for you as an N equals one person, how well is that actually moving the needle on your health? As a way of kind of calibrating it, deciding if it's effective, deciding if it needs to shift, and actually seeing a quantifiable result from it, which can be both analytically helpful, but also I think like helpful in terms of just like buy-in,
Yeah.
yeah, motivation to
Yeah.
continue. I think
I think
yeah.
that's the point is, yeah, hey, this is quantifiable, right?
Mhm.
We can actually, yeah, get something a little bit tangible, right? That you can go back and kind of look through and start to track over time. So I think
Yeah,
it's hard to make lifestyle changes, right? People get caught up in their ways, they're they don't realize that, how much they're drinking, or I don't know,
mhm,
traveling, right? Or having these external stressors and kind of the impact that can have on the
yeah,
underlying biology. So
yeah.
yeah, it's I think useful in that sense and way.
I'm fascinated and excited that you're doing a study on GLP-1s because I think I could be wrong. I mean, it might not go down this way, but my bet is that we are going to see within the decade that like at least half of the U.S. population taking these medications. Um, and there's just so much we don't know. I'm not saying that I'm against them, but it is true that there's a lot we don't know, and so um, I can't wait to see that because I don't want to get too off topic and controversial, but
Yeah.
I think there's just so much weird um, thinking around people's weight and around obesity that is really, frankly, like biased and poorly informed. And so I think people that don't understand the disease of obesity well and what people contend with that have obesity, they kind of think of this as like an unhealthy, dangerous, irresponsible thing that people are doing that is like incomprehensible. But when done well, I think it's life changing. And I think there we will see the more data on that and from a lot of different places in terms of like the obvious things, increased mortality or decreased mortality risk from just taking it, decreased risk of diabetes complications, heart disease risk. We're already seeing that data, but I'm curious to see too, like where it lands on your data. It sounds like, tell me more about it if you can, of like, is it basically like the patient's taking the medication anyway, and then they at certain intervals take a true diagnostic test?
Yeah, they would. To be honest, I actually am not as familiar with like all the
Yeah,
intricacies and the details.
yeah.
Um, but they would, I don't believe I don't believe it's healthy people like taking the GLP-1s, right? It's people who meet the actual
Yeah,
criteria, you know,
yeah, of course.
have type 2 diabetes, need to lose weight for XYZ reasons,
Mhm.
metabolic disease. So what's really cool about these studies and what gets me excited is that the biological age clocks should validate everything that you just said, right? If the
Mhm.
biological age clocks are,
Right.
increasing with age, and we have all of this data that says, it decreases risk, then like
Mhm.
something's wrong with the biological age clocks, you would say,
Yeah.
right? So they act as almost like validation based studies to
Mhm.
prove that what we're capturing is really correct. So I'm excited about the results. Always a little bit nervous with like this larger kind of clinical trial
Yeah. Yeah, I bet.
we're going through. But then if something does look a little off or it doesn't align with the hypothesis, because yeah, we'll all be blinded to the groups, and we won't know
Mhm.
who belongs where until after it's published and the data analysis is complete. Which again is a really nice thing to do when
Mhm.
you're doing kind of these cross sectional analysis studies with larger groups. Yeah, then you can dig into the findings a little bit more and understand maybe what's really changing, and you'll understand more of the mechanism of action of the clock and how it's working.
Yes. Yes. And the maybe of the GLP-1 med, because
Yeah,
I feel like
maybe
we don't
the
fully understand them, to be honest. There's receptor sites all over the body for that hormone. So,
Exactly.
Yeah, so fascinating. Oh, I can't wait to see that paper. I know it's probably years out, but I can't wait.
Yeah. Well, timeline should be hopefully, yeah, sooner than a couple years. I'll
Okay,
push
good.
for it harder. Yeah.
Okay, great. Good. I'm here for it. Well, Hannah, your testing is truly incredible. I'm gonna get my act together. I've been meaning to get a pace. I think you call the second one the pace. So I'm gonna do it, and it's just going up on my list to do. So tell me if people are interested in learning their intrinsic age, or how can they learn more about your testing?
Yeah. So anyone who's interested, they can go ahead and reach out, to me first and foremost, Hannah at truediagnostic.com. I'm always happy to answer questions. You can go directly to
Yeah.
the website though, and, purchase the kit. It's TRU and then DIAGNOSTIC. So
Hmm.
it's singular, not plural.com. And yeah, I recommend doing the complete kit to start and follow up, where it best fits and aligns with your regimen.
Awesome. Yeah, it's just I think of it as I mean just such a valuable thing. There's nothing else like it, and better now than later to get it, because I think we're always changing, and our environment's always changing, and we're always doing different things. And so I'm kind of thankful that I had a baseline. A little, like a lot's changed for me in the past year or so. So I'm like, oh, that's so exciting that now I can compare. I like how you can compare it across time. So yeah, we'll put the website True Diagnostic in the show notes. And thank you, Hannah, for offering to answer questions for people as well. And
Yeah.
very grateful. That's so generous of you.
We'll get you retested, Erin, and then we'll,
I'm
have to
gonna
hop
get
on a call and look at the changes if you want to.
It sounds so
I know.
dumb, but it's just like literally getting over the hump of like, how do I order the test? I just need, where do
Yeah,
I put my credit card? I just need to do it.
we'll get you set up. No worries.
Okay, sounds
Thank you
good.
so much. I appreciate it.
Thank you, Hannah. You're incredible. You're a genius when it comes to this, and thanks for making something that's just so valuable as a clinician and for the people that can use it.
Of course. Thanks, Erin.
You too. Talk to you later.